A ways off of just 4.2 light-years, Proxima b is the nearest exoplanet to Earth. And let's be honest, what's 4.2 light-years? Well, after all, that's 37.8 trillion kilometers. An enormous distance that already seems nearly unconquerable for us. Even the fastest probes of our time would require several centuries to reach the planetary system around Proxima Centauri. But does this mean that exoplanets like Proxima b will forever remain out of our reach? Well, not necessarily. In fact, scientists are already striving to turn the dream of interstellar travel into reality. The concepts involved are both heavy and strange. But how possible is it that the leap to the stars can be made in just a few years or decades? And more importantly, how should the greatest achievement in space travel be accomplished by the smallest probe of all time? It was in 1992 that the first exoplanets were added to the star charts with the planetary companions of the pulsar Lich. But now, over 30 years after the official first discovery, the list of our extrasolar neighboring worlds is a bit longer. In fact, we now know about more than 6,900 planets orbiting stars other than the Sun. However, that's not all. Some of these alien worlds are also under the exciting suspicion of being potentially habitable and possibly even harboring extraterrestrial life forms. This also applies to our close cosmic neighbor. Just take a glance at Tartan b, which is 12 light-years away, and tops the list of potentially habitable exoplanets. On the Earth Similarity Index, ESI for short, it achieves an exceptional value of 0.95. The ESI demonstrates the degree to which an exoplanet resembles Earth in terms of energy flow, mass, and size. However, be cautious. Despite the fact that Tartan b lies in the habitable zone of its home system, which allows for the presence of liquid water, we don't yet know if it is truly habitable, or perhaps even already inhabited. As is well known, official confirmation of extraterrestrial life is still pending, and our close exoplanetary neighbor Proxima b is no exception. At a distance of 4.2 light-years, Proxima b ranks 8th on the promising habitability list, with an ESI value of 0.86. Yet it also has a locked axis and orbits around Proxima Centauri, a parent star that has made cosmic headlines in the past due to extreme radiation outbursts. While the question of life remains unanswered in this case too, one thing is undisputed. If we really try to make interstellar voyages one day, there is no clearer destination than the Proxima Centauri system. But on the other hand, what seems so clear on paper sometimes feels far off in reality. Although the two Voyager probes have been flying through space for almost 50 years and have even passed the boundaries of our home system, they have not yet traveled a single light day from the Sun. Strictly speaking, the identical twin probes would need to fly for another 70,000 years before they would cover the necessary distance of 4.2 light-years. And if you feel that these ancient probes from the 70s are getting a bit old, consider that even a probe with current plasma and particle drives would require an estimated 40,000 years to reach the star system of Proxima Centauri. This spacecraft, however, should reach Proxima b in just 20 years. Nonetheless, this is the amazing part. Many experts are firmly convinced that the age of interstellar travel is inevitable. But it's in the nature of things that, where our current drive systems offer no possibility of progress, new ways must be taken to achieve the leap to other worlds. The fact that these new ways are not all that new on one hand, and yet appear very eccentric, is demonstrated by the core of the Breakthrough Starshot Research and Development Project, launched in 2016, with the cooperation of galactic greats like Stephen Hawking and Freeman Dyson. This project is based on a spaceship equipped with light sails, which is rapidly propelled by an extremely powerful laser. It builds on an idea that Robert Forward had already proposed in the 1970s. However, since a trip to Proxima b would be completely different from the journeys of our exploration probes within the solar system, the corresponding spaceship would also have to be adapted to the unique requirements of interstellar travel. In the end, this means that the scientists need to make the spacecraft very small to achieve the necessary speed of 60,000 kilometers per second and to survive the acceleration of several 10,000 g. A probe the size of a microchip would be required, along with a 4 by 4 meter light sail. This would only weigh a few grams. But then there's also the issue with the laser. To be exact, we would need not just one laser, but an entire array of powerful lasers joined together to form a 100 gigawatt beam, accelerating the tiny probe sail over a distance of 20 million kilometers. If the miniature probe is accelerated this way and raised to 20% of the speed of light in a very short period, it could then continue flying freely and reach Proxima Centauri in just 20 years. However, this will only work if the entire spacecraft receives its acceleration at launch. This is where things get complicated. First of all, a kilometer-long laser array would require the energy output of several power plants simultaneously. Moreover, the focused laser beam would also need to pass through the atmosphere, and we don't yet know what effects this would have. Have the sun as a light station. Luckily, there is also a more affordable approach in this regard. The probe could actually pass by the sun on its way to Proxima Centauri to recharge its batteries with light, and in this way, gain new energy. To do this, it would need to approach our sun to within about 5 solar radii. Simultaneously, however, it would also need to be equipped with a substantially larger light sail, since the sun's inherent power wouldn't be able to keep up with the immense force of the laser beams. A light sail of about 100,000 square meters would be required in this case. Galileo fans know that this corresponds to the area of 14 soccer fields. However, the appropriate material, given the cruising giant, might still be launched into space. It is possible that the key to material success is called graphene, an extremely light, ultra-thin layer of carbon atoms bonded in a honeycomb structure. In addition to this, graphene is considered a very stable material that could easily withstand the harsh conditions of space. Yet, as we know, the sail and the flight alone are not enough. After all, the probe would also need to decelerate somehow when it reaches Proxima Centauri and its companion stars, Alpha Centauri A and B. To do this, the researchers have calculated that the shuttle would need to slow down to a maximum of 4.6% of the speed of light, or 13,800 kilometers per second to swing into the system. A truly miraculous feat. The interstellar trailblazer could also use the help of the stars for this task. According to this, the probe could swing its sail at a distance of around 5 solar radii in such a way that it is decelerated by the light of the stars ahead. However, the travel time in this case would also increase 5-fold, as such a deceleration maneuver takes time. The interstellar flight would no longer require 20 years, but almost 100 years. Still, the effort might be worth it. After all, the simulations and calculations have shown that it would also be feasible to visit the planet Proxima b. To achieve this, the light sail would need to be adjusted so that the light from Alpha Centauri slows the probe down and steers it into the path of Alpha Centauri b. There, the probe would be decelerated again and finally launched toward Proxima Centauri. However, a small caveat is that these flyby maneuvers take more time, increasing the total duration to 140 years. Nonetheless, this would allow us to study an exoplanet up close for the first time. In this way, we could directly confirm whether Proxima b truly lives up to its reputation as the large twin of Earth. And who knows, if those in charge of advanced Starshot projects eventually choose to go with the laser option after all, and then also find ways and means to implement it, the journey to new star systems might actually become a reality sooner than we thought. But there is still a long way to go before we get there. The scientists estimate that the development time alone would take 20 years. Moreover, the execution of the project would require a workforce comparable to the largest global research efforts to date, such as those that preceded the creation of the CERN Particle Research Center. So what can we conclude? On the one hand, advanced Starshot is still far from becoming more than an ambitious idea. On the other hand, and this is the fascinating thing, it is at least theoretically possible to overcome the challenges of interstellar travel and to transform us into a species that sends its exploratory probes to distant star systems. And we'd now like to turn you into a species that presses the like and subscribe buttons. We'd love for you to join our community and never miss a new video again. We'll see you soon.